Okay, it's 12:21. 5 minutes, you can start.
Our topic is contribution of pozzolanic treatment on quality of different grades of recycled concrete aggregates in concrete. And I am Muronge Kristen Karimi with my partner Njuguna Alex Kibe with our supervisor engineer Odero.
For the background information, buildings undergo demolitions and therefore end up in landfills, and they can be recycled. But now the challenge comes into knowing the suitability of the quality of the rubble. In most cases, the quality is low and therefore creates a need for them to be treated. On to the problem statement, the rubbles will be of low quality than the natural aggregates, and therefore they will negatively influence the structural behavior in concrete, creating a need to determine the extent of the influence on concrete when treated. Onto problem justification, using them will ease the pressure on the quarry mines by providing an alternative source of aggregates, and also there will be a huge demand due to aggregates due to urbanization.
Our main objective was to determine the effect on the quality of treated aggregates and the performance of concrete. Our specific objectives include to determine the basic material properties of the treated and treated aggregates used in concrete mix, to determine the influence of the treated recycled concrete aggregates on the properties of fresh concrete, and to determine the influence of treated recycled concrete aggregates on properties of hardened concrete. Our scope included the pozzolanic treatments, which we used pozzolanic cement and rice as ash. Then we compared two samples, that was the random site RCA and the parent class C30 that was obtained from crushing a beam from the lab. Then we compared the influence of the untreated and treated rubble materials. Our limitations were we did obtain the rubbles from limited resources.
For the literature review, these are some of the studies that we reviewed, and after reviewing them, we found that the research gap was that pozzolanic materials have been studied, but mostly as partial replacements of cement, and also very few studies have used the slurry soaking method to improve the quality of the RCA.
Methodology, we first did the pozzolanic treatment, which involved mixing pozzolanic cement and RHA in the presence of water for pozzolanic slurry that was used for treatment. The RCA was soaked in the slurry for a time of 15 minutes, and the treatment period varied from 3 days to 7 days, with the RHA percentages varying from 0 to 15%. These are the methods that we used for objective 1, 2, and 3. Our results, we first did the Axeras test on the rice gas ash and pozzolanic cement, which we observed that the rice gas ash has a high percentage of silica 4 oxide, and pozzolanic cement has a high percentage of calcium oxide, which when reacts in presence of water forms hydrated calcium silicates that fills the voids in the RCA. The basic material properties of cement, we found consistency initial and setting time, which fit in the range. We also found the specific gravity of fine aggregates that also fit the standard range.
We also did the sieve analysis of the fine aggregates, and it was found it was within the envelope of the limits, and the fineness modulus was 4.14, indicating that it was coarsened. We also did the sieve analysis for the natural coarse aggregate, the RCA from the random site, and the RCA from the class C30 parent. Also, we did AIV treatment. We did AIV, and we treated the RCA for 3 days and 7 days. It was found that RCA generally is weaker than NCA, but when treated, it showed improvement, with 5% showing the most improvement. And also that is the same case that applied to ACV.
And the specific gravity, it fit the range between 2.5 and 3.0. However, for the random site RCA did not meet the threshold even after treatment. For water absorption, we noticed that after treatment, the water absorption was decreased by 40%, which was caused by the hydrated calcium silicate filling the voids in the affluent water. We also noted that increase in RCA and decrease in lime present in the slurry made the water absorption increase. We also did the SLAM test, which noticed that the more RCA we have, the less water we need for workability. And so the density, we noticed that after treatment, the density was strengthened because of strengthening of the affluent water in the RCA. Thus, it was improved because RCA has lower particle density, which makes RCA have lower resulting concrete density.
To the compressive strength, it was found that RCA generally has weaker strength than the NCA, but after treatment, it showed improvement, with 5% showing the most improvement. And also it can be seen that the RCA from the parent class C30 was found to have better results than the random site RCA, indicating that the parent class of the concrete has an effect on the compressive strength. Also, that is the same case that applied to the tensile strength, and also the tensile strength lied within 10 to 12% of the compressive strength. To the conclusion, There was a significant improvement in the aggregate properties, and 5% RHA showed the best results. And this is because RHA is a pozzolan which contains mostly silica, and therefore a certain amount of cement is required for it to hydrate so that it can form calcium hydroxide. And therefore it is found that when you decrease the cement by 5%, the properties begin to decline. But for water absorption, it was found as the percentage increased, the water absorption also increased. And also the treatment produced better treatment than 7 days.
Thank you.
All right, thank you for that quick presentation. So, questions from the panel members?
Now, what was the form of treatment, the 7 days?
We did slurry soaking method.
Come again?
Sorry?
What was the form of treatment? What is it? What do you mean by treatment?
By treatment is we soak the RCA in a slurry that's comprised of pozzolanic cement and RHA.
Okay.
Yeah.
That's let's say aggregate, eh?
Yes.
Yeah.
Oh, just the pozzolanic slurry. Where did you get the slurry from?
The slurry had to be obtained by mixing water, the pozzolanic cement, which we used 32.5 pozzolanic cement, and then we had to burn the rice as ash at a degree of 600 degrees so you can obtain the ash. Then we did the mix.
So this slurry is what? Is the cement and water?
And
the
rice as cash.
Yeah.
Oh, I see. Then you add the RCA to it. Yeah?
Yes.
Okay, then let me get this. So then you are varying what? RHA
The percentage.
to several percentages, eh?
Yeah.
To the cement.
Yeah.
Yes.
At the RCA, it was
constant.
It was constant, eh?
Yes.
Yeah.
Okay, fine then. So you're saying that you need a 5% as the optimum?
At the optimum, yes. Past 5%, the properties begin to decline.
Of CDO.
Yes.
Yes.
And the 3-day treatment.
Mm-hmm.
It's like a curing process.
Yes.
Yeah, it's like a curing process. It's a treatment period, but it's also like a curing process because you have to sprinkle. There has to be presence of moisture for the reaction.
Some reaction takes place. Also.
Yeah.
How many days did you check? How did you arrive at 3 and 7? Did you?
We got that from literature review. Most of them varied from 1 to 7 days. So we did a period of 3 to 7 days to compare on the both days.
Yeah, just 2 days. You didn't do a range like 2, 3, 4 something.
And no, we did not.
So okay, so you don't know what happens in between.
Yeah, we had a problem on the availability of enough material, so we had to choose on 2 days to be able to get results for comparison.
Then you need in your recommendation to tell us that we need to do operation so that we do more tests. I mean, you should tell us that we need to do more tests.
Okay.
Because you just picked 3 and 7 random.
Yeah, true.
Isn't it? Then in between results, you have no idea what is happening.
Okay.
Okay, so.
Yeah, thank you.
Okay, any other comment? All right, then we can stop it at that. Huh? Thank you for your presentation.
Thank you.
So it's now 12:34. You can start. 5 minutes, please.
Okay, our title is Effects on Recycled Concrete, Aggregates in Concrete with Glass Powder as Part of Cement, presented by myself, Legwa Gilbert, and Salom. Our supervisor is Mr. B. Motua. Directly into the introduction, owing to development and infrastructural development in many countries, it has resulted to high demand in materials, depleting reserves and increasing costs. Thereby, there is more production of materials, for instance, something like cement, which leads to more global warming during production. Therefore, it has come then to researchers to come up with sustainable methods, eco-friendly methods in engineering to find solutions and come up with materials that can help mitigate this issue. Thus, we propose treatment of cement and fine aggregates with crushed RCA and CGP. Our problem statement included mitigating the process of manufacture of cement so that we can reduce the production of CO2 causing global warming. Also noted that sand is depleting at a very high level, increasing demand and degradation of rivers, say floods, the breaking of banks. So noted that there is an haphazard and disposal of glass. For instance, the picture shown there, bottles that are disposed. They are non-biodegradable, can cause bodily severe injuries and possible problem of disposal. On towards justification, resources getting overstretched and resulting in being insufficient. Therefore, need to come up with a plan. Therefore, we pegged our research on the reduce, recycle, and reuse method of environmental sustainability. It also occurred that proper management of glass ensures that there is reduced injuries, clogging of drainage, reduced concrete production, and enhanced environmental protection. You cannot peg all this on this statement, right? Contributes towards the lowering cost of construction, promoting green environment, and providing beneficial to researchers contributing to alternatives to concrete, harnessed for civil engineering purposes. Our main objective was to evaluate the effect of crushed glass powder on concrete with recycled concrete as part of fine aggregates. Our specific objectives include the physical properties of ingredients used for concrete, the workability of the fresh mix, strength of properties of the hardened concrete. Research questions included, does it affect positively or negatively performance of concrete, it being hardened, and the actual effects on the fresh concrete. A scope provides clear design of the physical performance of CGP and RCA, performance of hardened concrete, class 25, and we pegged our research on cement 32 and bamboo. And to a limitation, time was a limitation, of funds also could be a limitation where more research is required. We also noted there could be a variation if cement brand varied, glass type varied, concrete class varied. A literature review. Researches that have been done have shown that there is a major concern in the reduction of cement replacement done by...
Show us the gap, please. Okay. In the interest of time.
Research gap. Limited research has been done on the double effect of the combination. Thus, we realize it is a good topic to research on combination of glass and recycled concrete.
On methodology, on methodology, the research was carried out through experimental research approach, where we have sample preparation, preliminary test, mixed design, and then fresh concrete and then concrete. The table it is showing the concrete the design mix as per the concrete aggregates. Materials testing. In aggregates, we did seed content, particle size distribution, specific gravity. On glass and cement, Indian consistency, setting time and soundness. On workability, Indian slump, and then concrete, Indian compressive test. On sieve analysis, there is a graph of sand that is fine aggregate, which is shown there. The recycled concrete, the other side 4.2. And it is implying that both were within the required limits, hence they were recommended for use in research work. Grade comparison of river sand and recycled concrete, sieve analysis is done there, which was found to lie within the required limit. Therefore, the physical properties of crushed glass powder cement, consistency of crushed glass powder cement. From the results, the consistency increased in the amount of crushed glass powder content increased in the mixed sample up to 1% crushed glass powder composition in the cement as shown in the table. This is the need from the this initial and final setting time, whereby the more the amount of cement content, the less setting time recorded. On workability, we did the slab test, which is shown as per the table. Compressive test, which we varied, which shows compressive strength variation of recycled concrete crushed glass concrete, which was done after 7, 14, and 20 days. Conclusion. Objective 1, best working combination was 10% RCA in the fine aggregate and 1% crushed glass powder. Objective 2, the best water cement ratio was maintained at 0.47. Objective 1, CGP and positive impact on the strength and concrete meant with the RCA at 10% 3%. Recommendation, there is a need to encourage researchers to take up research courses on these ways to determine their engineering properties. Need to develop codes or guiding standards on the use of various waste.
Okay, all right. Thank you. Thank you for that. Let's get a comment from panel members. Engineer Kabubo. Any comment? All right, Engineer Odero?
No comment.
Okay. I also don't have comment on this. Unfortunately, I was looking at something else here that have just come up. So you can exit, it's okay.
Thank you.
Okay, you have 5 minutes, it's now 12:03, you can start.
The title of our presentation is Investigation on the Performance of Banana Leaf Ash and Bacola Powder Admixture as a Partial Replacement of Cement in Concrete. And hereby, your presenters, Solomon Goloman, our side, Mohammed Abdullahi Muhammad, and our supervisor is Ibrahim Mutua. For introduction part of it, concrete plays a major role in structural development, and with its main constituents as water, cement, aggregates, and other materials such as reinforcement. As you can see, a figure here showing the application of concrete for concrete structures. So this research aims at investigating the viability of some other natural materials and agricultural waste in replacing these conventional materials for concrete. Problem statement. With increased population, it has led to growth of slums in this country, and therefore there is need to transit to better housing, which therefore increases the demand for such materials such as cement, which have a negative impact on the atmosphere. Problem justification. This research aims at utilizing Bacola powder and banana leaf ash in reducing cement production and also reducing environmental pollution. Objectives. Main objective of our project is to investigate the use of banana leaf ash and Bacola powder in concrete mix to improve the performance of concrete in construction. So the specific objective here is to determine the physical characteristics, to evaluate the workability, and to determine the strength of concrete. Scope of our study, the potentiality of banana leaf ash and Bacola powder in concrete. Here we do the workability test, compressive test, and the tensile test. For the limitation of this study, the time and everything, we are going to do provide more on our studies in masters. So the previous researcher, Ayaba ATL, the Sakatir, Marfirsal Ali, and Gosbi Rajal. So for the research gaps, most of the related study concentrate on the strength properties of concrete using agricultural waste, giving less attention on physical properties of the state of these materials. This is the breakdown of the methodology that we employed in our research. For objective 1, we did the coarse sieve analysis for coarse and fine aggregates, specific gravity for coarse and fine aggregates, setting time for all these materials, cement, Bacola, and banana leaf ash, consistency test, cement, BLA, and Bacola. And the procedure is as outlined in the code, specification of code listed against each of the tests. For objective 2, we did the workability test for fresh concrete, and for objective 3, we performed the compressive strength and split tensile test. Chapter 4, for results, analysis, and discussion. These are the results for fine aggregate gradation. And our gradation was successful because the grading envelope lied between the limits provided by BS H12. As well, this is for coarse aggregates, as you can see. The specific aggregate, for coarse aggregates, we obtain a value of 2.67 and a water absorption of 2.99. For fine aggregates, we obtain 2.64 and the water absorption for 2.957. Consistency test results. Here are the consistency test results for cement, Bocola, BLA, and a combination of the two. Setting time results for cement, Bocola, and banana leaf ash, as well as the fineness test, which we use to determine the proportion of the weight that were not passing the required BS size, the micron size. These are the results. These are the results for the fresh concrete, the workability. We did a mix. We performed 4 mixes, 4 batches of concrete mix. That's one for control experiment containing 100% cement. Another one, 5% BLA and 10% Bocola. Another one, 5% BLA and 15% Bocola. And the final 10% BLA and 5% Bocola. Here are the results. As you can see, the slump decreases. This is probably due to high water absorption by banana leaf ash, which was evident from the consistency test results. For densities, here are the results. We realize that the densities.
Can you conclude, please? 1 minute remaining.
Conclusion. Both the compressive and tensile strength of concrete decreases with increase in cement replacement. The slump loss increases with increase in replacement, in cement replacement, with highest increase in 10% BLA and 5% Bocola. From this research, the optimum percentage replacement of cement that yielded higher strength was 5% BLA and 10% Bocola, with a slight decrement in strength to that of 5% BLA and 10% Bocola, 15% Bocola, sorry. References. That's the end.
Okay. All right. Thank you. All right. Let's get the question now. Before I invite members, let me know. Have you looked at the work done last year?
Yes.
Concerning the use of Bocola soil?
Yes, we did.
What did they recommend about the characteristic or the properties of Bocola? And what motivated you to use it in your research?
Bocola portrayed the same, almost similar characteristics as that of the compressive strength of control mix, which was 100% for their case. The compressive test results differed almost by a small value.
So there was no contribution of the Bocola, is it?
Yeah, there was, because as much as the aspect of cost is concerned.
Not cost. I'm talking about the material itself, because the last year's group, they did even the chemical analysis.
Okay.
Of that material. If you read that work, yeah. So now I'm seeing you are combining with the
banana leaf ash.
With the banana leaf ash, and my concern is what are these good characteristics or qualities or properties that you found in Bocola soil from previous study that now you say these material have got these features, and we believe now if we bring in the ash from the banana, then it can be able to improve ABCD. Okay.
Yeah, the study of last year, they showed that this Bocola soil has some simultaneous properties, which has a lot of gypsum. So we got that as an idea. We mixed with the banana leaf so that we can replace it with the cement.
So from last year's category, what did he classify this Bokora soil? I mean, how did he said it behaves more like what? Cementitious, poposoranic, or what?
Cementitious.
You sure?
Yeah. Yes.
I think in your document, you need to include results from last year.
Okay.
And build your work from that so that somebody will understand why you motivated and then why are you bringing in the banana ash fiber. I mean banana fiber ash. Then research gap, the one that you gave after the literature review.
Okay.
You're saying most of the studies concentrate on strength properties of concrete using this, giving less. So this is your gap. This kind of your gap is on what?
Physical properties of these materials were less research. Things like the fineness test and the consistency test for these agricultural products that can be used in place of cement.
But I'm telling you, last year the people who did Bokora, they even did the chemical test analysis, which you have not done. And you don't even need to do it. You have not even brought those results here. And they did it very well, I think, from the Ministry of Mining.
Yeah. Okay.
Yeah.
So we based that as our literature review aspect.
So if that's a gap, then let's see the objective.
Okay.
I don't know, somehow I feel that gap not convincing, because it's like you are concentrating, or you are saying your research will focus on the material or the characteristic for the individual, the constituent materials, but we are seeing the tests are just the normal. The first one, the physical, actually you are talking about physical characteristics, not even mechanical. Then we come to workability, so we move to concrete. So I believe it's better to get a more convincing gap. The gap you are saying there, to me, is not very convincing. You get my concern. I don't know whether you get my concern. Because the test that you are doing, actually the gap I was looking forward to is, somebody have done on banana ash, is it? Banana leaf ash. Somebody else have done on Bokora soil. Then you want to use them together. What was the deficit when the materials were used separately that you believe when you combine the two would bring some improvement? That the gap would be the inadequacy or the deficit when the materials were used separately. You look at maybe the chemical composition of Bokora soil, you look at the performance maybe from previous study of the ash from banana leaves, then you say, based on these features, right? And based on this deficit and the good and the bad, you evaluate both the positive or the positive characteristic and the shortcomings. Then you say, if we can combine the two, then they can complement one another. So the gap to me is not like people have focused on concrete and not on the physical, the properties of material, because almost all people who do these studies, they start with the characterization, material characterization. Most of them, right? So to me, your work, because again, you did not do it only on the physical characterization, and then you say, I delved so deep on this physical characterization of this particular material, but you went ahead, did the same standard test that people do on the chemical, the physical characteristic or the mechanical characteristic, then you went ahead to, you made a mixed design, and then you are proportioning, changing the proportions. So the gap should, to me, think about it, and I'm happy that your supervisor is also logged in now. You see whether you can beef it up so that it's more strong. I'm not disputing the work you have done, but the gap that might not adequately represent all the tests that you have done. Because you did more than just these physical properties. But here the gap shows that that's your concentration. Well, that's the point that you are concentrating in, which is not necessarily true from the result that you have shown us. Okay. Engineer, you are here?
Oh, thank you. Sorry, today I've been terrorized by the internet.
Sorry for that.
Okay. Now, the Peters, You've told us about this Bokola. It's the second time I'm getting this name Bokola, word Bokola. Are you aware of the guy who graduated last year? There are some students who worked on this material.
Yeah. Yes.
Yes.
Yeah.
I know it is too late to talk about maybe the difference in the study, but have you checked what they did that probably you wanted to bring out here for the interest of the studies being different?
Yes. Yeah,
Yes.
we were just aiming at observing the strength properties of the contribution of the compressive strength and all that when these two materials are combined.
Oh.
Yeah.
Now, what interesting thing did you find out?
As you can see from the compressive strength test results, you can see these were the results. Like for instance, this for replacement of 5% BLA and 10% Bocola, the result at the age of 28 days was almost similar to that of it was 99% of the target strength of our control mix.
Why? What is so special in Bocola that is making it have that kind of strength?
From the literature review of the previous studies, it had some best calcium oxide composition.
Oh.
Yeah.
Only calcium?
Calcium oxide, silicon oxide, and all those chemical composition.
Maybe you need to provide that in your literature review to support your work.
Okay.
Thank you.
Actually, I was telling him that the previous group, they did the chemical analysis. He could bring that information here in his work.
Okay.
Yeah, you see, even the gap he's talking about, he's talking about physical properties of the agricultural materials. You know, fibers are being used for agricultural products. So he's talking about banana leaf. You know, it's actually a statement for the gap is very weak actually. It's like it's not there. Maybe you need to frame that gap. That statement needs to be reframed, eh?
Yeah, show us the slide number 9, please, so that others can see what you're talking about.
Actually, wrong, totally wrong.
Okay.
Physical properties. Some, you see, the properties of the fiber are physical properties. And a lot of work has been done on fibers for concrete. So that is actually wrong. Maybe you need to look for another thing to support your gap actually.
Okay.
Then in a nutshell, what is Bocola powder? Where do you get it from? From the shop, from wherever?
Hello.
Yeah?
We obtain it from Mandera.
From?
Mandera.
It's mined or something.
It's a natural occurring soil.
Or it's a natural occurring?
Yeah.
It's only in Madeira.
Yes. Especially those in northeastern parts.
Okay. From what kind of stone?
Pardon?
Well, what kind of natural material is it?
More of a natural occurrence.
How has it developed over time? From weathered rock or whatever?
No, it's just a form of soil. It's just a form of soil.
Eh?
Just a soil.
Oh, it's a soil?
Yeah.
And you see now, as the other panels have said, panelists have said, without properties,
yes,
I can pick soil from anywhere, and they call it Bocola powder from Kwale or something.
But that one seems to be so finer, just almost.
No, again?
More finer.
You can also crush it and make it fine. What I'm saying is that you support yourself you know, this is a material you're using for research.
Yeah.
Without properties, it's just a name. Somebody could have called it Madeira powder or something.
Okay.
Did you?
Yeah.
Okay. Then the results you got 5% at something else, eh?
Yeah.
How does it compare with the need with the control?
They slightly decrease with the increase in replacement, percentage replacement.
Yeah, you gotten the optimum, eh? Oh.
Yeah.
How does it compare with the control? In terms of strength, is it lower? Is it?
The variation is very small.
And then okay, fine. Then the other thing is, how extensive is this powder in Madeira? Is it very common?
Yeah, it's very common.
If you do 2 houses, you not finish it or something?
No, it's in large. It's in excess.
It's in excess.
Yeah.
That's what you need to tell us also. I mean, because you see, if it's excess, if it's just a small, you know, a small whatever quarry.
Yes.
It means after you do 3 houses, it is gone. Then it's not worth a research.
Yeah.
But you need to tell us that in your literature that is extensive. Okay.
Yeah.
That you can build the county headquarters and some other things,
Okay.
and then you can still be able to continue with the whatever, with the material. Okay. Okay, Chair, you can.
Okay. Thank you.
Yeah, Chair, how are you?
I'm fine, thank you. Welcome, Baramtua.
Sorry, I had a parallel meeting in the morning. Eh?
Yeah, yes, I am.
You know, I don't understand my students. Eh?
Yeah.
They just came in when they were just being grilled. Eh?
Yeah.
It's a question I can hear everybody asking. They never did material properties of that material. Is it true?
No, the chemical property. We didn't do the chemical property of the research.
Anyway, Chair, it's okay. We'll deal with it before they finish.
Yeah, and we are also awarding marks. Eh? it can be captured in terms of the marks awarded.
That's what I'm saying. Yeah, we have noted very well.
Yeah.
Okay, fine. So I'm around.
Okay. We have 2 more of your students remaining. Eh?
Okay, fine. And
we also like to invite you. You can raise comment or question because these are just a few of us remaining.
Exactly. That's okay.
Okay. Okay. You are ready?
Yes, we are.
So it's 13:07. You have 5 minutes. Can start.
Yes. So our project was
Can you check your audio? Hello?
Hello?
Yeah, your audio is faint and again it's breaking. Eh?
Can you hear me now?
Yeah, now you have come back.
Yes, that was our project title.
Okay.
The effect of sugarcane bagasse ash. For back information, we're just showing how the use of soil blocks has been here for decades. We're also showing the use of sugarcane construction for adequate housing. There's also a high cost of construction, most people in slums. From garbage, which we solve by again. Our objectives were, we have the main objective, which is to find the effects of the bagasse and the strength properties of the blocks. Then we'll determine the properties and classify the soil, which we are to use for making the blocks. We are also to determine the dry density of the blocks, with the sugarcane bagasse and we were also to investigate the strength and absorption properties of the blocks. So we have literature review. This is true.
according to the for the population, predict increase numbers in the urban areas coming. So we have summary of previous studies. We have shown previous studies of ash being used to stabilize blocks. We have shown the use of lime. According to those studies, the use of the ash has higher strength properties in the. So for sugarcane bagasse ash, we also a few studies that have shown to be a pozzolanic material that, according to STM 618, natural pozzolans must consist 70% silica, alumina, and iron oxide. And sugarcane bagasse ash, according to this chemical composition, we got from which has been provided by the sugar factory from Kakamega. We can see that sugarcane bagasse ash meets those requirements for a pozzolanic material that can be used as a stabilizer. So for our research gap, we show that sugarcane bagasse ash has been tested for stabilizing of blocks before, but there has not been any of the fibers and the ash being combined together to show increased strength in the blocks. Okay, so for our results and data analysis.
For our results, data analysis, we first we did tests on us. So in the moisture content test, we found that average moisture content became 13.5%. The liquid limit test, we found that the liquid limit was 25.4%. We found 7.45%. From the plastic liquid limit, we found the plastics to be 0.655%. In the linear shrinkage test, it was calculated to 1%. From those results of those tests, we classified the soil into the US standards to be local. We mixed our soil preparation, our soil mixture. We mixed it with 0% fiber, 0% sugarcane fiber, 0.5% fiber. Then the bagasse 5%, and 15% by dry weight. Then we tested for compressive strength after the soil blocks. The tests were carried out after 14 to 28 days of molding the bricks. The strength of the block for each day of testing was obtained by testing the compressive strength of 3 block samples. So the compressive strength for the 5% on average for 14 days was 2.25.
1 minute remaining. 1 minute.
Sorry. The 10% was 2.68, 15% was 2.96. For average after 28 days was 2.531 for 5% ash, 2.5 for 10% ash, and 3.648 for 15% ash. So we saw that the compressive strength of the blocks increased with the introduction of the ash content, and then increased with further increase in ash. And then the Kenya standard specification specifies that at 28 days, the compressive strength should be greater than 2.5. And at 28 days, we had our 10% and 15% sample meets the requirement of the standard. Then for the dry density, calculated we oven dried the blocks, 3 blocks from each mixed ratio at a temperature of 105 degrees Celsius. Then the blocks are weighed, the density calculated, and we found the average density for the 5% to be 1385.8, for the 10% to be 1330.21, for the 15% 1308.66. The results of the density, the average density, it decreases, increase in the sugarcane bagasse ash content. For the water absorption test, the dry blocks are weighed, the weight recorded, and then the block mass in water for 24 hours. And then we saw that the average water consumption also increased in sugarcane gas ash. And the minimum allowed water rate is 15% for soil bricks. For the conclusion, so we classify soil plastic waste. Find the ash contributed and the density of blocks, the compressive strength.
Okay. That's it. We can read this. Let's get questions from the members. Question, comment. Engineer Odero. Okay.
Thank you for the presentation. Now, what is it that you can say at the end of the day? What is the contribution of your research material to what you are testing?
There has been a lot of studies on the of soil using this material ash, but we are not seeing any study on the sugarcane bagasse ash. So that's okay. Yeah.
Okay. So now, do you think it was worth doing this study?
Yes. We got that 10 and 15% makes the required limit, and it should be advisable.
Okay.
Yes.
Thank you.
Thank you.
Okay, Engineer Kabubo.
Now, how would you protect the fiber from rotting?
How would?
Sorry?
The fiber from rotting. The fiber. The fiber is going to rot in the block. How would you prevent it from rotting? After 2 years, there will be no fiber.
Oh, okay. We did not think about that, but rotting is supposed to by water content. So if the water is too much, then the rotting is much.
Come again?
We did not consider about the rotting.
So can you read the literature? Can you read a bit on that?
Yes.
Yes. So then, what made you do this research?
We met with our supervisor. I had seen a lot of juice vendors in Juja with a lot of sugarcane bagasse, like the waste. So I thought we could do. So meeting the supervisor, we realized that there was an gap. So he advised us to try.
Did you do a whole panel? Did you do a whole panel? Or just the blocks?
Yeah.
You just did the blocks, or you did a wall? You tested a wall?
We did just the blocks.
Just the blocks, eh?
Yes.
Just the blocks?
Yeah.
What kind of strength did you get? What kind of strength did you get?
Got
the strength.
We got the strength.
With the optimal, you got an optimal.
Yes, all of for the 10%.
Did you?
For the 10 and 15%, yes.
Come again?
For the 10% and 15% ash.
What was the strength?
2.68 after 14 days. Yes. 2.68 for after 14 days. 3.5 and above. MPa. 3.5 MPa and above.
Okay, so you can, it means the standards, eh?
Yeah.
Okay, so sawa. About the protection of the fiber, eh?
Yes.
Okay.
Okay, thank you for that. Any other question, comment? All right. Just from what you have read,
Yes.
I don't know whether it's on slide number 22 or before that. Again, go back. Yeah, here. Does the size, the length of the fibers have an influence on maybe some properties like the compressive or the split tensile strength test of your blocks? Maybe from literature, from what you read or from what you tested. Okay, maybe you did not vary the length, but I want to know whether maybe from previous studies they have studied the issue of either the aspect ratio or the length even.
They had not studied it, but they had recommended a minimum length of 5 to 10 meters.
Based on what?
A previous study that had been done. That's what they had recommended as the length. But they had not actually tested it against, it was just what they had used.
And you agreed with them, eh?
Yeah. There was no way for us to test for that, so decided to go with that length.
You see, what I believe is,
Yeah.
in fact, you know, we build from other people's work.
Yes.
So what I believe is that from recommendation from previous people's work, then you build up on it. You do something extra.
Yeah.
Yeah. Okay. I know now you are bringing the aspect of combining the two, but to me, I would have even thought of now that they just they did not tell us which is the optimum fiber length. So maybe concentrate on the aspect ratio to see which one is the optimum. What's the length that we should incorporate in our soil matrix? Because I know there is a fiber length, a short one that might not be having the impact. Yes, especially when how are they acting? The fibers help in the tension, is it?
Yeah.
You don't expect them to contribute much in the compressive aspect. So even if you are doing the compressive strength test of the block, they're kind of holding together the soil particles or that matrix, is it?
Yeah.
So the aspect of the length then can come into play. But anyway, was not a concern of your investigation, but it's also good to think about the contribution, as Engineer Odero was asking, what's the contribution of your work?
Okay.
Okay. All right. Well, I think no other comments. Thank you. You can exit.
Thank you.
Yes. Can you see our screen?
Can you see us?
Yes. Continue.
Yeah. So I'm Julius Juma Mkuyuni, and my partner is
Laura Namenya.
Our topic is improvement of red coffee soil with rice husk and coffee husk for sub-base material. The background: construction of road is a vital development in support of socio-economic well-being of the society. Road pavement is made up of different layers. We are trying to improve the red coffee soil because it's to stabilize with some stabilizers like coffee husk and rice husk. Problem statement: red coffee soil has high plasticity, more than 15, and low CBR of less than 30, values limiting for use as a sub-base material. Common use stabilizers are lime and cement. Environmental pollution, which causes they cause pollution if not well disposed. The stabilizers. Justification: red coffee soil is improved with rice husk and coffee husk ash that are readily available to meet PI less than 15 and CBR more than 30. Reduction in general cost of construction, which leads to reduction in the general cost of road construction, and utilization of agricultural waste products, thus avoiding environmental pollution. Our objective, the general objective, is to investigate the stability of improved red coffee soil with different percentages ratios of rice husk and coffee husk material for road sub-base construction. Specific objective they include to determine the physical properties of rice husk and coffee husk and red coffee soil. To determine the Atterberg limits of red coffee soil after improving it with coffee husk and rice husk. To determine the CBR of red soil after improving it with rice husk and coffee husk. This research mainly focused on examining the suitability of improved red coffee soil sub-base with rice husk and coffee husk, whereby CBR and Atterberg limits tests are carried out from soil laboratory. Our limitations, there were many, but the main one was in situ tests. Literature review.
Okay, we got to the literature review, a review of the previous studies. The first review was according to Al Hassan, 2% to 8% rice husk ash was used. And the studies achieved sub-grade. We also go to Brooks. The study achieved sub-base 2. And to Thapan, the OMC decreased from 24% to 18%. And it was recommended that with
that a maximum number of trials with different proportions of ingredients were required to be carried out. And we also go to Mamuye, addition of coffee husk ash, there was a reduction in PI and OMC, and achieved sub-grade quality, but according to there was a gap in terms of further studies were required to be carried out. And also it was required to be found that the different effects that coffee husk ash has on different types of soils. So we got to a gap. Mainly, previous studies have focused on rice husk ash and coffee husk ash used separately for stabilization of subgrade, but none has focused on their combination for use as stabilization material for subbase. Okay, we go to the methodology. Objective 1. The tests, the procedure, the references, specific gravity, moisture content, hydrometer, procedure according to BS 1377, part 2. Data analysis as indicated. We got to objective 2, Atterberg limits. So we found that with varying percentage of coffee husk ash with rice husk ash, there's reduction in the liquid limit value. Yes, we got to the plastic limit. We found that the increase in coffee husk ash and decrease in rice husk ash led to the increase in the plastic limit. We got to the plastic index. There's a decrease in the plastic index from 20, that's of neat soil, to 14.1. We got to the linear shrinkage. There's also change there, which is decrease. We got to the objective 3, California bearing ratio. So we found that the CBR of neat soil was 9.8 and it improved to a value of 22, but did not attain the standard. We got to the swell. Also, the swell reduced significantly. We got to the conclusions and recommendations.
So neat red soil is unsuitable for use as a road subbase material since it did not attain it had a PI of 20, which is greater than 15 according to the road design manual. The CBR was 9.8 for the neat soil, but after improving it, it should be at least not less than 30. The plasticity index reduces with increase in coffee husk ash, and decrease in rice husk ash. The optimum increase obtained was at 100% of coffee husk ash, which attains a PI of 14. California bearing ratio of red soil and coffee husk ash and rice husk mixture is soaked in soaked condition increased significantly from 9.8 to 22, but it did not attain the road design manual standard, which should be 30 for the road subbase. So our recommendations, it should be used now, since it did not attain the values, it can be used for road subgrade, partial replacement of rice husk ash and coffee husk ash with a stronger stabilizer like cement or lime. An optimum soil and coffee husk ash and rice husk combination should be clearly established in order to determine if it can achieve the subbase standards according to the road design manuals. Thank you. These are our references. Thank you.
All right, okay. So let's get the comments from the panel members. Engineer Odero?
Yeah, I think the presentation was okay.
Thank you.
I don't have further comments.
Thank you.
Okay. Engineer Kabubo? All right. Mr. Mutu, do you have any comment on this? This is the last presentation, eh?
No, I think they are okay. They are okay.
So what happened with your slides? You are scrolling.
We converted
to PDF. So we had,
even after you convert to PDF, you should be able to move page per page, not scrolling, eh?
We are using the touchpad. We don't have a mouse.
Oh, okay. All right.
So can we exit there?
I'm trying to remember what you are presenting. I'm just trying to remember what you are presenting. So you're saying even after improvement, we can use this as sub-base material? Or not?
Upgrade, yes. Because the subgrade standards according to the road then manual. Yes.
So usually, what material do you use? The conventional material for stabilization?
We use cement. Yes.
So the issue of course could be something interesting, eh?
Yes.
Yeah, in future. Okay. Thank you. Thank you. You can exit.
Thank you.
And that brings us to the end of our presentation.
Yes.
Thank you everyone for your participation and for your cooperation. I'm glad that we are able to move on with speed today. We had a few issues just of connectivity, not like the last year's one, so I'm glad on that. So what do I say? Just to wish you well in your upcoming exams and even as you prepare to finish your studies.